Okay, it's time to start our review session. So we're gonna go until 2:30. There's about 25 questions in the quiz, so we've got, I don't know, 3.5 minutes per question, but some of them are pretty straightforward. So the ones that you have specific questions about when we reach them, we'll be able to take some more time with them. Otherwise, we'll just get through some of them more quickly, right? So you might have had time to take a look at this final, the solutions, I think, published as well. So you have the answers, but that's not going to help you for the final tomorrow. So if we start at the beginning here, the first question that's asked in this final is, what is the most important difference between a class and a struct in C#? Yeah.
Structs are in place, whether that be stack or heap, wherever it is created.
Yeah. And what are classes? Objects.
That's the only thing I would recommend.
Yeah. So that is the difference, and the difference is because objects and classes are not stored in place, right? They're stored on the heap, and then you have a reference on a stack somewhere to them. So you'd have to.
The class has an overhead that has that reference pointer, and structs don't. They just have everything right there.
So when you create a struct, it's stored in place. So let's say you created, and it's stored on the stack, right? Then you have the whole struct there, everything it contains. But if you create an object of a class, then all that would be on the stack is a reference pointing to the actual object that's stored in the heap, right? So that's the difference right there.
Yeah, that's what I mean. The struct doesn't have that overhead pointer. A class does.
Okay, yeah, that's a difference there, yeah. So that would be one of the reasons why you'd want to use a struct instead of a class, right? Okay, so that one's pretty straightforward. Let's go to the second question here. Well, actually the second question, I don't think you're gonna be asked anything about this. You haven't been taught about this principle.
He said on Piazza that we never talked about that.
Yeah, if you're curious, you can Google it. Okay, in what aspect of software engineering does forming and testing hypotheses play a key role? How would you approach this question? Yeah.
Is it debugging?
It is debugging. And how do you know that?
I just look at what the question is saying I'm doing, and I think, what am I trying to do? So it's like forming and testing hypothesis. So I'm trying to test the problem and find the answer. And so the only time I'll be in my book, I'm trying to debug it.
Yeah.
So that's
Yeah.
how I do it. But
Right. And you can remember as well, it's not something that we haven't discussed in class. He talked about it in the beginning of the semester, I think, about how the ideal is that we'd debug or fix our programs in a more scientific way than just random guessing, right? You form a hypothesis, you test it out, can you replicate it? And then if your hypothesis is good, you're able to do it. So it's a more meticulous approach to debugging, right? Rather than just putting a breakpoint somewhere and then see what happens. Right? You have to think about it. So the answer was debugging, yeah. Okay, this is a little more interesting, at least to me. We've got a method called compose, and we're given a contract, the declaration, and then an empty code body. And what we have to figure out is, what is the implementation of this method? What are some things you would want to look at when you get a question like this? Yeah.
what this method returns.
What it returns, right? And here it returns a func int. Func int is the version of a method you can store where it's taking in an integer and it returns an integer, right? What else would you look at? Yeah.
One of the PAs mentioned look at the size of the space you can write in, because if it doesn't fit,
Okay.
you're wrong.
Yeah, yeah. Right? You have enough space. But sometimes you get too much space, right? So that's... What about the contract? That's the first thing I would look at. Like, what is this supposed to do? Because sometimes it's tricky. You can have a method name and it says something, but it doesn't necessarily mean that that's what it does, right? You have to look at what it does. It says here that it returns h, such that this function h equals the function f with the input of the function g. So if you're in a test, that might be something to, you could write down, right? You could say, okay, what happens, you put something into g, something comes out from g, it goes into f, and then this function f that this method is supposed, this function h that this method is supposed to return, that should be what it returns. So what does that tell you when you know that you're supposed to return a method? Lambda expression, right away. Yeah. So we want to do a lambda expression. And this is a fairly simple one, I believe. You just literally just make a lambda expression that, yeah, f to g to a essentially returns that. Okay. So what if you got a different question and it was using an action instead of a func? What's the difference there? What was that?
Actions are void, so they don't return anything.
Yeah, they're void. Right. So those are two good things to remember. Always keep an eye out for what kind of method is it, func, action, what does it do, what does it return? Yeah.
For a function, is it the second, like, so there's like the two ints right there. Is it the second one that's is it the last that's the return type, or the first?
The last one.
The last one?
Yes. Yeah. Okay. Any questions about this one?
So,
Yeah.
well, I'm just really looking at that question.
Okay,
What
sure.
would that look like?
Yeah. So with a lambda expression, you want to. Okay, I'll use parentheses here just to make a point, but you don't generally need parentheses. But you want to have some parameters, right? And then you have double equals in C# I think, an arrow, and then you have something here that's what the actual method does, right? And if you wanted to put in multiple things, like a whole body, a whole method, instead of declaring it elsewhere, you could use the curly braces and then just have the implementation in there. The most simple ones, like in this case, you just have one variable, let's say x, and then you'd want to return if g, I'm doing this with a mouse, it's kind of hard. I believe something like that would work. Does that make sense? Yeah.
Do you know if you have parentheses around the x right there, would that still work?
That does, yeah, it works. It doesn't make a difference. It just looks more compact if you have just one variable. But if you have multiple variables, I think it's nice you put in a parenthesis and you can do a comma b comma. Okay. Does that clear up how you use them? So that's really it. Anytime you want to use a lambda, you could use it in those ways, and you can replace any method with it if you want. Sometimes it's not worth it, but a lot of the time it's pretty neat, like in this case. So in this case, you'd want to return this method. So this lambda expression, it evaluates into a method. right? Remember that methods can be stored as just values. So you can literally just return the lambda expression and values into the method that you're returning. Okay. Okay.
Aren't you supposed to return like a func on the last one?
Yes. So, okay. That's a good question. So, func is declaring the type of the method that you want to return. And if you look at this, it takes in a variable x, and then it returns whatever that evaluates to. And we know that f and g take in an int and return an int, because the declaration says that in the parameters. So this is a method that takes in an int and returns an int, right? So it matches func int int. So you don't have to explicitly store it. So you don't have to say func int comma int and then a variable name equals to this lambda expression. You can just return it. Not that you couldn't do that. Yeah.
So just to recap, so it's returning that whole lambda expression. It's not returning, let's say, whatever you pass in, and then it would only return one thing. And I'm saying like, well, whatever you pass in, since func is something that takes in an integer and will return an integer. So it's not just returning an integer; it's returning the whole method.
It's returning the method. Yeah.
Okay.
Yeah. If you wanted it to just return an integer, you'd have to change it to an int and then evaluate the method first.
Okay.
Did anyone else have a question about that one? Okay. They're pretty important to understand. We've been using them once in a while, but they're good to have in the back of your mind. So number 5 here, we've got a method shuffle. Print shuffle and shuffle. That's what they're called. Not that that matters. And this deals with enumerating the yield returns. So in this case, you've been given some hints, right? You get a contract. Like in the previous one, we start looking at it and we look at what does it return, what is the contract, what is it supposed to do. You've been given one method that's already implemented. So that's a good thing to, you could look at that. And we know that I1 and I2, they are infinite enumerations. You know what it means to be an infinite enumeration, right? I've talked with some, at least with the midterm, where there was some confusion. Are you allowed to do this loop while true? I mean, is it going to be stuck in an infinite loop? It's not. It's an enumeration. You get one thing at a time, but it'll continue infinitely. So we've got I1 and I2 that are infinite enumerations. And then this print shuffle is supposed to print the elements of I1 and I2 in an alternating fashion. So let's say we have, I guess I can draw this in. We've got I1 here, and it has a bunch of numbers, I3, 1, 3, 5, okay? And it goes on to infinity. And then we have I2, that could be 2, 4, 6, like the even numbers there. So what it's saying is that this method is supposed to print them alternating. So first, it prints the first element of I1, so it'll print 1. Then it's supposed to print 2, the first one of the next one. Then the second of the first one, then the second of the next one. So it will be 1, 2, 3, 4, 5 in this case. Okay. And so the question is, how do we implement shuffle so that that happens? So we'll definitely need some yield return. Right. I don't know if I want to write all of that with my, this is a yield. So we do need some yield returns. What's going to happen if that's all you have?
Yeah, just try to.
Yeah, once you're done with the second one, it's just going to exit. It's nothing more. So it's not infinite. How do you make it infinite? While true. Yeah, you don't have to be afraid of that when you're doing enumerators.
Can you go into a little more depth on why that, if it's an infinite, whatever it said, an infinite enumeration, why we can do that while true? Can you go into that once more?
So if you were in a normal method that's not an enumerator and you did while true, it would stay in there forever, right? In this case, when you're doing an enumerator and we're using this yield return keyword, so the way to think about it is that each of those yield returns is like a kind of like a breakpoint, I guess. So the next time you get into it, that's where it's going to continue. So when you say right here, it says move next up here, that's going to go to the next one, and then it's going to stop until you do move next again. And that's why you can do it, because you control when it goes to the next thing. You're not stuck in some infinite loop. Does that make sense? So how it does that specifically is, I mean, it restructures it so that that works. Yeah.
With move next, would that ignore the first index, or would that give the first index?
It would start from the beginning.
Oh.
Yeah.
So in his implementation, he used move next and current to yield return.
Mm-hmm.
When I was doing it, I just did like, before I had my while statement, I did like int I 0, then while true, yield return I1 of I, yield return I2 of I, then I incremented I, still in the while loop. Why would you not want to do that? Why would you want to move next?
Let me see if I understand you right. You're saying that instead of his implementation where he's doing a while true and then move next on the first one, you'll return that one, move next on the second one, you'll return that one. You're doing a loop where you're incrementing a counter.
Right.
And then I suppose based on that counter you would say is it even or not even to determine which one you have to return?
Sorry?
How do you determine which of them you have to return?
Well, I thought we were supposed to return both, but like you return I1 first, then I2 second.
Yeah, yeah. You will only return one of them in one iteration. So you have to distinguish between which one do I want to return this time around. It would probably work, you could probably make it work, but you'd have to make some comparison that makes sure that you know when I'm on this counter, I need to return from this iteration. When I'm this counter, like number, I guess even numbers or uneven. Sounds a little complicated to me, but it might work, yeah.
I guess the question with that is with IEnumerator, can we get indexes? Or is there no way of getting that since we don't know what the enumerator is?
You don't need an index. So you don't, this goes to infinity as well. You have like an index of infinity. Okay. Anyone else have a question about enumerators here? Okay. So if you get a question about these things, just be conscious. Is it an infinite enumeration? In this case, you're dealing with 3 different enumerators, so you'd have to make sure when if you're using the move next that it goes to the correct thing, and that depends on what the question is, but you could draw it up like I did here, have the 2 enumerations.
Is it a given that IEnumerators have those .move next and .current methods in them?
It's part of the
Okay, it's part of there and it's in the API.
it's part of the interface. It's an interface. Yeah. done a lot of multi-threading, so this is a good refresher. So if you have n threads running at the same time, what he's asking here is how many runtime stacks do you have, how many heaps do you have, program counters, and how many copies of the program code. Yeah?
N stacks, one heap, N counters, one copy.
Yeah, exactly. How do you know that?
Because we know there's one heap that each thread shares,
Mm-hmm.
and then each thread has its own stack. So if there's n threads, there's n stacks, and we all know that they're all looking at a read-only copy of the code. So there's only one code, and then each thread needs to keep track of its own counter.
Right.
So each thread has its own counter. So
Yeah. Exactly. Yeah.
What's the program counter again?
So program counter is how it knows where you are in the program code. Yeah. Which is why you need more than one, because they are different places. So if you forget it and you're like, oh, I don't know how many it has, you can always reason, right? And think, if I have them running, I need to have different.
For the copies for program code, is that only true because we're using it's in C#, where we have the because it's the kind, it's like a reference to the code versus
No,
everything has its own copy.
no, I don't think that's language dependent.
So just for clarification, though, is the program counter the same thing as the RIP register on the x86 CPU?
As the what?
As the RIP register, the instruction pointer?
So yeah, I guess so. I could be mistaken, but yeah, there's a counter in there, and it would. I mean, once you've compiled it and it goes into machine code, it would be some instructions that it would point to, not what you see.
So for this problem, it says that we have one multi-threaded program. If we had more than one multi-threaded program, would each multi-threaded program have their own heap, or would there just be one heap shared amongst all the multi-threaded programs?
This is per program.
Per program. Okay.
Yeah, like the whole application.
So every if there was more than one program, they would each have their own heap then.
Yeah, like yeah.
Oh, okay.
Each has their own virtual memory going on. I don't know if they've gone over that in 38 till now, but yeah. Okay. Yep. So databases. It's fresh in your memory probably. So there's two different questions in this final about databases. This one is asking you to make a query. So a good idea would be to just refresh all the queries you've been making, simple ones, and they're pretty intuitive because they're very close to how you would say it normally. Like you want to select something from this one, and you want to do that where this is that. That's generally how you make the queries. So if you don't remember the syntax, it's not a big deal. I mean, you can probably guess it. But with these two tables, we've got people that has ID, name, and age, and then we've got cost that has ID and car. And so what you need to know here to answer the question is that paragraph underneath it where it says which one has the primary key. That's the ID in the people table has that one. And then we know that the ID column in the cost table has a foreign key constraint. Foreign key, do you remember what that does? Yeah?
isn't it the key that shows up in another table?
I'm not sure what you mean by that.
So since ID is a key in the right table as well as a key in the left one, wouldn't
Okay. Yeah, so it's if I understand you right, then yes, it's referring to that this ID in cars has to be this ID in some ID in people. Yeah. Okay. So for clarity, the example it says is Anne. If you look at Anne right here, her ID is 1. She's 32 years old. And then we can look at cars and see there's one that has 1 right there. Which means that she has a Ford. Because that's her. Yep.
So you said the ID in the cars table was the foreign key, right?
So the
foreign.
yeah, the ID column in the cars table is a foreign key.
So
to the
how do you distinguish between which one's primary and which one is foreign?
It's in the problem.
Oh, is this it?
so each table can have a primary key. In this case, in the cars table, you've got a foreign key constraint instead. But in the people table, the ID column is the primary key. Yeah.
Will the primary keys always be unique?
Yes. Yeah. So we want to make a query that will produce a table containing the name and age of everyone who owns a Ford. How would you do this? Yeah.
Could you do select name, comma, age from people, cars, where people.id equals cars.id?
Where people.id equals cars.id.
And then so where cars equals Ford.
Yeah, you can do that. And just make sure that it's car. It has to match the column name for it to work. Yeah?
I have 2 quick questions. For the car equals Ford part, in the solution does and car equals Ford.
Mm-hmm.
But are you supposed to do like cars dot car equals Ford, or will it pick up just car equals Ford?
I think, I don't think you have to, but let's say different tables have the same column name, then you might want to be explicit.
And will like the in cars, will the people ID also be a foreign key
No, it won't.
for cars primary key being ID?
No. Well, wait, sorry. So you're saying the people ID, if that will be a foreign key to the cars?
Yes.
Yeah. No, it wouldn't be.
Is there a certain like sequence you have to like do there? So like do you have to construct a table with the primary key before creating the one with the foreign key?
Well, anytime you make a foreign key constraint, you need to have something that it's a foreign key to. Like in this case, you can do it because yeah, okay, because it'll essentially point over to that one, right?
Right.
If you don't have any table that point to it, it doesn't work because of foreign key constraint. That's what it means. It means that this has to exist in this other column somewhere. Yeah.
Does a foreign key have to map to a primary key? Or can it be just any?
I don't know what would happen if you have duplicate entries. I'm not sure.
It's usually mapped to a primary key
Yeah.
for that, but it's
I
like
guess you could try it out. I haven't tried that out, honestly. Yeah. So what would happen if you try and delete Anne from people now? Or if you try to delete Ford from cars, would it work?
You can delete Ford,
Mm-hmm.
but if you delete people like and before, if you delete the primary key for Ford foreign key, it just goes to shit.
Right, exactly. Because then it no longer has anything that it's referring to.
didn't he say that you can decide which way you want the database to handle that? If you delete and, then delete everything else, or
Oh,
whether not to do it at all.
yeah, I'm sure you could. Yeah, but
But in most cases, it just won't do it.
generally, I believe the default is that it wouldn't do it because that would break up your database.
If you like go into the database and like try and delete it, it'll like error out.
Yeah.
If you make a method, yeah, you can have it, if you want to delete something that's a primary key, go for delete everything that's a foreign key and then the primary key.
Or like something or something, yeah.
Yeah, that was it.
Okay. There's another question later about databases, so we'll get back to that. Question 8 here. So in C# we've got properties. In Java you don't have properties. So you just have to make these getters and setters. And so the question is, why is it a bad idea to have a public instance variable? Yeah.
It allows for arbitrary sets.
Excuse me?
It allows for arbitrary setting.
Yeah, arbitrary setting, okay. Okay. Did you?
Just that you want to control access to the variable between like other classes and stuff like that.
Yeah, so the control, why would you want to be able to control this? Like what difference does it make? It's not like they can just get the value and put stuff into it, which they're going to do with your getters and setters anyway, you could say.
A public instance variable has no restriction on its like modification.
Yeah.
So anything can be set to it, or you get it at any time, and there's nothing that keeps it.
So you're thinking like a security concern, or what? I'm not sure.
Yeah, like if you want to have, well, I guess it's saying a public instance, not public static instance.
Yeah, just a public instance variable, so it's specific to the object. So that's another reason. If you've made this public and you have people who start depending on the use of this variable, and then you make an upgrade to your code, you have no way of modifying the behavior of when they get things and when they store things, if you need to, because they're dependent on it. And so by making a getter and a setter, you provide a way for you to be able to change in the future the behavior of getting and setting this variable if you need to add something around it, calculations, something else. And that way you can change it and it'll still work for whatever client is using the method. Otherwise they're going to have to change it somehow, right?
This is more of like, is what you're referring to is like, you can change what you're returning when they use the getter and setter? Is that or
Yeah.
when they use the getter?
Yeah, because that's a method. You could do some calculations. You could format it in a certain way if you wanted output to be formatted a specific way. You can't do that if it's just direct access. So I believe the wording he used is, yeah, once it's in the public interface, so where clients start using it directly, it's difficult to eliminate and impossible to customize, right? You can't really, it's out there, it's too late. And people don't like it when they have to change all their code just because you want to change your class. Yeah.
So if it's public, you can't really change it once the client is using the interface. Is that basically what it's saying?
You could change it, but it makes it more difficult
Okay.
to remove it. Like even if you, let's say you wanted to remove it, but people have that method there saying get, instead of this variable you're going to replace it with something else. It's not going to change the functionality. It could be that you have a case like that. If you have a getter and a setter, you could just change what you return over to a different value.
Okay.
But you can't do that if they had direct access to it. Then you have to change and let them know they have to change something.
I thought you could because like initially when it's public, like you could like set it to anything for security reasons. That's why it's not a good idea. Because everybody has access to changing it.
Okay. I'm not sure I
My
follow.
question.
Yeah.
Because the reason why you would want to make something public as an instance variable
Mm-hmm.
is because for security reasons, somebody can actually from the outside change the instance variable. Let's say if a method depended on how many times it was called, and somebody would have changed, and if it was public,
Okay, yeah. So you do get some more control. If you only wanted them to have a getter, you can't do that if it's public. Right. That's also true.
Okay.
If you already have a setter, then you're changing the variable anyway. But you could wrap some security measures around it, I suppose.
Okay.
Okay. Okay. So question 9 here is from the intellectual property lesson, and this is the kind of thing that I wouldn't remember. Yeah.
Is it trademark, copyright, or sorry, trade secret, copyright, trademark, patent?
Yeah. That's it. So I'm assuming you didn't get that from the solutions. So how do you get the answer? Do you have it written down what each of them are, or do you actually reason somehow that that's that?
Well, I had to deal with it a lot before.
Okay.
In terms of copyright.
So you're just familiar with it.
Yeah, but
So that's a good
like
thing too.
relies on secrecy, trade secret.
Yeah.
Creative expression. I just think of like YouTube, like everybody says, oh, I don't own the copyright, so it's all on YouTube. Branding,
Okay.
I just think of like markets, trademarks. I
Marks.
really don't ways of remembering it.
No, but it works. If you remember it, it works. See, I could remember the trade secret and trademark one, but for some reason I switched around the copyright and patent thing. So that's something I have to like. I know they're not the same. That's just me. I would have written that down somewhere so I could remember it, because I'm not too familiar with it. Otherwise, if you are familiar with it, that's great. Straightforward to just write down 4 words or 5. Yeah.
So what was the last one? French novel ideas? Is that one?
That one was the patent.
Okay.
Yep. So, question 10 here is the ethics from yesterday, I think. No, I don't know. So, what is the overriding consideration in determining ethical behavior? That's, you can etch that into your brains somewhere.
Is it intent?
And intent, I don't follow.
Like whether or not you meant to do a bad thing?
Okay. Okay. I guess it's related, but you can be more specific, yeah.
Contributes to society and human well-being.
Mm-hmm. Yeah, exactly. In his words, the public interest, right? How it contributes to society. Does it damage it? Like what you said earlier there. Is it illegal? So, ethically, software engineers should have the overriding consideration of the public interest.
Off the top of your head, do you know what ACM is? Is it like Association Computing Machinery or something like that?
Something like that, yeah. I don't know. Okay, so we get a flashback to the spreadsheet here. So it says that we get these first few lines of a spreadsheet, and it has a dictionary, and it has this boolean whether it's been modified or not. So you recognize something similar from your own projects. The problem is that whenever this person runs all of the tests, they fail. But when they run them one at a time, it goes good, goes well, passes. So what is the problem? That's what you have to identify. Yeah.
It's with the dictionary being static, right? It's that when it's static, it's shared across every single, well, I'm not so sure anymore.
Second doubting yourself?
Yeah.
Yeah.
Static dictionary,
What about the dictionary?
it's being shared against all the
Yeah.
spreadsheets rather than non-static.
Yeah, it's exactly like what you said. Yeah, because it's static. It's one dictionary for all objects, right?
All of the what, I'm sorry?
It's one dictionary with the
Spread across for every
for
spreadsheet.
every single spreadsheet. They share the same dictionary, and that's problematic. Yeah. So anytime, I mean, it's likely, based on what I've heard and what people have asked me to help with, that you've experienced this, where you're passing them one at a time, but not when you run them all. And it's got to do with things like that. Something is being accessed or shared between all of them, and it's not working when it's run asynchronously. Static, that's what you should look out for in those cases. And if you've experienced something else, you could see it's there, but that's a big one. Okay. Okay. Do you remember what a pipe is? It does move stuff, yeah? So you had the pipe and filter assignment, right?
We did?
That was like the first assignment.
Oh, yeah.
Yeah. You remember that one?
No.
So would the answer to this question be a file because of the Unix systems, everything's a file?
I doubt that would be the answer. But yes, you are right. In the Unix system, everything is a file, which is also an integer, but you don't need to know that yet. Yeah.
Moves data to one program standard out to another program standard in.
Yep. Yeah. So I mean, you're saying a file, but the thing is, earlier you said
Data.
yeah, you say data. That's more specific. So it's not just a file, right? You created these projects, and those were the ones you passed in, right? They wrote from standard in, or read from standard in, and they wrote standard out. Yeah.
I want to make sure, say, filter right here is right. Would it be correct to say the result of one filter being a parameter for the next filter? Am I using filter correctly there?
Yeah, it's a filter. Yeah.
So like
Being input to the other filter. I don't know if you could say it's a parameter.
output of one filter becomes the input.
Yes. Yeah. That's just like he said, you're routing the standard out from one into the standard in
I
automatically.
just wanted to make sure I wasn't using filter wrong.
Yeah. Right. So that is exactly the answer to this one. Now, there was something else that you had to do in your pipe and filter assignment. Not being asked about it here, but it's a review session, so I'll mention it. Do you remember what these things do? So the pipe is this one. Yeah? Yeah.
They pass in the contents of the file or push your output to a file.
Exactly. And it goes in the direction of the arrow. The way it's pointing. Yeah. And it's called redirection because you're redirecting the output to a file specifically, not to another filter, like you're not piping it, it's just to a file. Okay. Question 13, which of these terms refers to the type of testing that is particularly important during the process of modifying a program that has previously passed a set of test cases? So what I would do here is just look at each of them. Does it fit it? Does it not? It's only one of them that fits it. Is it black box testing? No, it's not. It's not white box testing. I think the confusion here would be, is it unit testing, and what is this regression testing thing? Is regression testing.
Did we talk about that? I don't remember talking about regression testing. I remember black and white box.
I remember. Sorry. He did talk about what this means. I don't know if he mentioned regression as a term, but what it means.
He mentioned regression specifically, but we went over the other three. So I think this question is like making sure we know it's not the other three. Just
Yeah, I mean, I guess so. Well, this is not your final though, so. But regression testing, yeah.
What's the strong argument on why it's not unit testing?
Yeah. Well, you'd need to know the difference between unit testing and regression testing. Regression testing is if you've got a set of unit tests that you've already run and they're good, they pass it, then you change something and then you run the same test cases to see is it still okay. That's regression testing. Unit testing is just the whole thing you make unit tests.
Testing is just too broad of a term.
Right, because you could make new unit tests and that wouldn't be regression testing. Does that make sense? Okay. Okay. So we've got this class, my list. It's got a bunch of instance members and some methods. And then there's this public static void if method. And we're being asked, we're calling the method if, and then when you reach this the third insert, and when you reach the end of the loop right here, it says when before the third call, immediately before it terminates, so the very end, not the end of one iteration. Okay, what does the stack trace look like? That's what you're being asked. I believe he said that you wouldn't necessarily have to draw anything for your final, I don't remember, but you should still be able to do this. So you draw up a stack and you say what happens. You start an F, you go into the constructor, this one moves into the constructor up here, something's initialized, it's passed into list, and then you go on. So this is not, you don't have multiple threads going on right now, it's just one chronologically. Push it onto the stack, pop it from it. Okay? And so when you draw a stack, I'm not saying that you will necessarily have to, but drawing a stack, you've got this box, it's a stack, and then you've got some stack frames, and the function f has its stack frame. You can be explicit in how you draw that, doesn't really matter, just make sure it doesn't look like a normal variable. Yeah.
In C# or struct, you use the stack row.
What was the question?
I don't know, I think it's from top to bottom, but this is an intuitive way to draw it when you're just thinking in broader terms. The question was, in which direction does the stack grow in C#? I don't know that it's any different. I might be wrong. Normally it's from top to bottom. But you don't have to draw it from top to bottom. Okay, so in here we get list. This is the function f stack frame, right? So you can draw that list up, and that list is a pointer to an object which is my list. And what does that contain? Well, that's the instance ones right there. So you can put those into that object. And one of them is a pointer. Oh, okay, I can't draw it there. Forget this one. To an array that in the beginning contains 2 elements, like it says right there. Okay, so that's where you start. Yeah.
So the array isn't in my list. My list contains a pointer to the array.
Arrays are objects, so they are not stored in place.
Okay, I just didn't know that you could have multiple pointers like that.
Yeah, sure. You can have a pointer anywhere.
Okay.
You can have an array with pointers to another array with pointers. You can have arrays of arrays of arrays if you want to confuse yourself. Yeah.
The solution on line, it uses like this keyword. Can we leave that off? Is that fine to leave that off?
Not if it belongs there, I believe.
So like, I'm just trying to think of like when to use like I'm very confused like in the situation when you would write this.
Well, when can you use this?
Yeah, like
in
on
those
stack.
cases, it exists, right?
So if it exists.
So when you're in a method in an object, you can always do this this dot something, right? That means that this exists.
So if you're in an object, then there's this available.
I believe so. Yes.
Okay. Because I was confused. Like in the online example, they wrote this keyword.
Yeah.
So in the solution, it has list pointing to numbers and then pointing to your just like you do, and it has this pointing to size. It says size is 2. I understand that the size of the array is 2, but int size equals 0. Is that not what this size is referring to?
So the image right there is the result, and right now we're not at the result. We haven't even gone into insert once, but the result is once you've reached insert the 3rd time, and the 3rd time are about to exit this loop. That's what the result is showing. So what you'd have to do, well, if you wanted to draw this out to make sure you got the numbers right, then you draw. First time you go in, what happens, which values, and it gets popped off once you leave the scope of that. So the first time you go in, you'll have a stack frame here that's insert, and it's the first time, the one with the parameter that's 1. Once you leave that one, that stack frame is popped, and then you go into it the 2nd time. But in the meantime, some values have changed, and that's what you need to keep track of. How do these values change as things go? So how does the stack frame actually look in the end?
I guess I'm not. So is this size that it says is 2? Is that the int size, or is that the size of the array? Because I'm not seeing the size being incremented.
The size is the one in the object.
What's that?
You mean this one, the size here?
Yeah.
That's this one up here.
Which
it starts out at 0, but then it's incremented at the end of insert.
Oh, okay. So we go all the way down to that number size.
Yeah, this method is called.
Stopping where that arrow was.
Only on the 3rd time through.
Oh, on the 3rd.
Yeah.
Okay, I'm
It
sorry.
says the 3rd call right here.
Okay, I'm sorry.
Yeah.
In this situation, is size incremented after or before you insert in the 2 numbers?
So you have this one, and then you have this one.
Right.
One is a post increment, the other is a pre-increment. And if you have it pre, it's before, that's this one. If you have it post, it's this one. And as the word says, post increment means that you get the value and then you increment it. Pre means you do it before. So the one where you have the plus something, that's going to be incremented before it's actually passed on. The one where you have x plus plus, you give the value x, and then once that's done, afterwards you increment it. Does that make sense? Yeah, so that's it. Okay. Any other questions on this one? So you know how to approach something like this. If you get a question and it'll say, what are the values in the stack when you've reached some point? Make sure you know what point it is. Make sure you know what the flow of the program is, and then you can just go through it, draw it, push pop. And
So
stuff.
we go over when list insert equals 1. So then what I'm seeing is that list is called, means that object, my L, size is equals 0, numbers is given to
This one's 0.
yeah.
Yeah.
So it's gonna skip that. So the numbers is number dot size is gonna be 2.
That's this one.
Yeah.
2.
Yeah. So it's gonna go here. Means it's gonna skip that if statement.
Yeah.
For
This
the-
2 is
for the-
not 0. Then it's going to go down here.
Yeah. So in that part, is it gonna make so the size is gonna be increased to 3, right? And it's referencing that number array, right? Since it's an object.
Yeah, so it's referencing, so numbers here is this array that's out on the heap. And then size is currently 0.
Yeah.
So it's going to say that numbers at 0 is n, which is 1. So that's going to be in here. And then it's going to increment size, so that ends up being 1. So the next time around you've got a size of 1.
Okay.
Yeah. And then the next time you come in, n is 2, size is 1, numbers length is still 2, and that evaluates to false. And so it's going to do the same thing. Second one here becomes n, which is now 2, and then it increments, so size is 2. And then the difference comes when you go in the third time. You go in and now 2 is equal to 2, so that's true. And so you actually have some stuff happening in here. Right. Is that good? Okay. Okay, and the 15 is just the fact that you have a heap as well. This is the start. 14 is asking for that, 15 is asking for this out on the heap. It's separated into 2 questions, but it's easy to do at once. Okay, true false, kind of. Which one of the following statements is false? And this deals with REST services. So I would suggest remembering the assignments you've had and how they functioned, how you actually worked with REST. In this case, if you look at a REST service can be built on top of the HTTP protocol. Did you do HTTP calls when you were? Yeah. So yes, it can, right? So you can remember how you've used it, and then you can eliminate the ones that you know are true here. Is it concerned with user interface details? Yes, it's unconcerned. Yeah, that's true. I said concerned. Right. So you did make an interface for the buckle, like a GUI, but that didn't change the service in any way. And we know that you've been using JSON, so D is true as well. Okay. So this is the next database question that I mentioned, and we sort of went over this. It's checking whether you understand foreign keys, primary key, uniqueness constraints, things like that. Okay. So if you have a names table so it says here we've got a names table. This is the names table, and it has 2 columns, a social security number and name. Then you've got the phones that has 2 columns, social security number and phone. And now you want to make sure that the names table can never have more than 1 row containing a certain social security number. So how do you do that?
So the
Primary key, yeah. And so in this case, there's also, you could also use a uniqueness constraint. Primary key will work. Yeah.
Can you go over the difference between those real quickly?
So you can have a primary key, but maybe you have another column that you also want to be unique. Then you only have 1 primary key column. So you can have a uniqueness constraint where you need it.
So it's just a row that's unique.
It's the same thing, it's unique numbers. Yeah.
So
Or unique entries.
like use uniqueness constraint on social security numbers.
Yeah, that would make it unique. Yeah. Or make it the primary key, that would also make it unique. And then you also want to make sure that the social security number in the phones table, that they have a matching social security number in the names table. And that's the foreign key constraint. Right? And it's a foreign key where the phones table here has a foreign key constraint over to the names table. Yes, yeah. Okay. Okay. Question 19. I think you had a question. Didn't you have this on your next? Do you want to renew it? Did you all understand it?
Will you go over the 2 small one more time?
Okay. So the problem with it being too small is that you, so as it says right here, ideally critical sections should be as small as possible. So if it's smaller than that, it's too small.
Oh,
So let's say you have multiple things you need to do, but if you split that up, so you only do 1 part, but you depend on that second part being done in the same critical section, then it's too small, and that breaks up your I don't know, remember what the word is. Yeah.
The answer I put that got a right answer was it's also more expensive to make small locks because big locks is expensive. So that was also a valid answer.
Okay, yeah, so if you have a lot of them that you don't need, that's an overhead from every single time you need to do it. That's another reason why you wouldn't want to have them too small. Does it make sense why you wouldn't want them to be too large? Yeah?
That defeats the point of the multithreading.
Does defeat the point, yeah. Good. Okay. Then you should review your Git. You've done a lot of commits and stuff. And it's checking if you understood what you've been doing with Git. So the scenario here is you want to help with an open source project, and so they've got this repository on GitHub somewhere, and it's a read-only repository. So what do? You clone it. So you actually put it down on your own so you can start working with it. Yeah?
Why would you clone instead of branching?
You don't have it yet, right? The first thing you have to do is clone it. It's read-only, you can't start changing it on GitHub. It's not like publicly you change whatever you want on GitHub. You have to clone it first and then you can start doing things. And then you've repaired a bunch of bugs, you haven't tested it, but you're done for the day, okay? So you committed.
So branch would kind of fall into that too, right? Like create like a sleeping branch or whatever. I know you have to commit before you branch, but would that be plausible?
I mean, in the process you would be doing a commit, but the branch itself is not needed for this. Branch would be useful if you want to go down a new path and you don't want to lose what you've already got, you don't want to change it. So you make a new branch and you try out a new idea and see if it works, then you can merge it back in or something. Or in your case you have a work branch, so you don't put your official solution.
Right, so it's
with
like you have a wake branch and a sleep branch.
I guess so.
Ideally, in this case, it's always using a branch.
Yeah.
Can you say commit and push or just push? Since you have to commit in order to push?
Well, once you've committed it, it's a good idea to push, but once you've committed it, it is in your local repository. The push is useful in case something goes wrong with your local repository, like you lose your computer or something.
Do you think it would be incorrect to say commit and push?
I don't think so. It would be a reasonable thing to do.
Well, you might not want to push to be unaffected.
Yeah. I don't even remember what the official answer was, but you want to commit it.
It's
Just commit, yeah. It doesn't have the push.
I just felt the branch could be an answer, because if you do all your work on your sleep branch, you still have that one you can go back to, but I understand when it's fine.
Yeah. Like you'd have to commit it anyway. The branch itself doesn't.
That's what we were saying.
Yeah. Okay. So, fair use. So there was like 4 things that he mentioned about fair use. Purpose of use, nature of work, amount of work used, the effect of the use on value of work. So things like is it commercial or educational, that stuff, which I've written down because I don't remember it. But you have to take those 4 things, go through these 4 things and say which one is not a good argument for fair use. Right.
I pretty much thought what would hold up in court and what wouldn't.
Okay. I think it's B. I don't have the answer here.
It is. It's
Yeah. Okay.
Well, it's asking was not an argument that constitutes fair use.
Yeah.
So it's fair use because there's no copyright on it. It would be fair use because the DVD isn't for purchase, and it would be fair use because it's educational for a history class. But just because it's a DVD on a certain documentary, that's not fair use. So it'd be A.
Well, no, it's educational.
No.
A is
For
the
them all.
Yeah. Because even if you don't have a notice, you still have copyright on it.
because like you were saying about writing stuff.
Did you have?
Well, so fair use, from what I've understood, is it just if it's for educational use or if it's not for money? What's another example of fair use?
I think another thing you said is fact versus creative. So an argument against A would be the fact that it's fact-based rather than creative.
Yes, and there's also, I don't remember which ones you just mentioned. So commercial, educational, right?
You have educational and then not for money.
Not for money, right? But there's factual versus creative. Then we have the scope. Like, is this a small incident or is it like
Well, the scope
very
of it.
large
So
of your use?
is that like if it's like over 100 or 200 years old?
Like, how much of the work are you using? Is it just a small clip of something, or is it the whole video?
Like a photo scan of a page or something.
Yeah, just a page or the whole.
Like 15 seconds of a video or like 30 seconds of a song, something
Yes,
like that.
yeah. So that would be a consideration, and then it would also be how much does it go out on the business that you're using it from, or the person, right? So does it cost them a lot of money that you're doing this, or is it not really any difference? That's at least the 4 things that I understood from it. But I would review that on the slides. Okay. Okay, question 22 here. It's not a tricky question. It just is just exactly what you did in your assignment, right?
Drag and drop.
Drag and drop, and then what did you do?
Google.
Yeah. Yeah. Then you need to add an event and implement the event or something. Yeah. And then you have a button that works.
So drag and drop and implement.
Yeah, but you might. I mean, specifically, it's an event that you're adding an event and implementing it. I don't think there's anything else to it. No. Just
That's all you put. You put drag and drop event handler and implement the event handler.
yeah. Because once you've done that, it works. Okay. So the last bit here, if I remember right,
We don't. You said that we didn't get into sockets enough.
right, but you do get it in. You may get something in terms of string sockets. So this question is specific on sockets, but we can go over the same idea that you would be doing in your string sockets. What you'd review for this kind of question is how did you send things? What was the process of sending it? And the callback, how did you use that? This is sending it with bytes, but you have been doing it with string sockets, so that's how you would, what you would be expected to know, right? Or how do you read things through a string socket?
In this case, like relating it to bytes sent to bytes length, is that kind of saying like this is the final send that we're giving?
Yeah, so with the string socket, you're doing this line by line, and you keep reading, for example, or sending until everything has been sent. I believe the string socket actually sends everything for you and then calls the callback.
Yeah.
But in this case, you are not guaranteed that everything has been sent when the callback is called. So at some point it says, okay, I've sent something, and then you keep track of how much have you actually sent, and then you keep trying to resend until everything has been sent.
So like
And that's how that works.
bytes sent equals or is the same as bytes length, then we know that this should be the final, so we keep trying to make sure it sends and then finally pulls.
Yeah, yeah. So it's
Keep trying to send.
yeah. So this is just a keep going until everything's been sent kind of thing. So I don't know if we need to go over much with that, but I would make sure with the string socket you just turn in the assignment, review how you send it and how you receive it, make sure you understand it well enough, the process, and then I think you should be fine. So yep. So we've still got 15 minutes. If there's anything else you've got questions for, that's what the rest of the time is for. Yes.
In the database example, we use the dot product. Is it okay if we use the inner join instead of the dot product?
Dot product. And the one in the top?
Yeah, it was like the one where we were joining the two tables together.
This one.
Yeah.
I'm.
So for our example, we used like the dot product to join them. So we did
Okay.
like the table, comma table. But is it okay if we use an inner join instead?
I think anything that is a SQL query that produces the desired outcome is good. And you could do it in a lot of different ways. Just be careful on not overcomplicating it, because it's most definitely going to be something where you could just do it in a straightforward way like this. But if you're more familiar with doing it in that way, I think that would be fine. Just make sure that it actually does work.
Okay.
Yeah. Anyone else have questions before we go? Okay. Well, I'm gonna turn off the recording, and if you have any questions, just come on up.